This video will fundamentally change how you look at the world. Most people are unaware of the fact that different portrayals of the Earth influence how we think about global politics, culture, and population. This video is going to walk you through the different types of coordinate systems and projections that are commonly used and how you can use them to better portray the world as we see it. I'm going to walk through devices that you can use to remember the differences between different projections, as well as a quick run through on how to do this in QGIS. A note to anyone who is not familiar with QGIS, it's a completely free software. So you can simply go and look up QGIS online and download whatever version is right for your computer. A quick aside for people that are looking to go into GIS professionally or are currently studying GIS, this is a underemphasized area of importance. It is so important that you understand the differences between commonly used projection systems. Not only is it going to be a good conversation starter at whatever sort of GIS meetup that you go to, some of the world's largest companies, i.e. Apple, Docs, or Google, they're going to ask you questions like this in an interview. How do I know? I've been through several Bay Area interviews and I stuttered my way through my coordinate systems. It is not a position that you want to find yourself in. So make sure that you pay attention.
Hey, if you're ready, here we go.
Simply put, a coordinate system is a way of using numbers to mark a certain location on the Earth's surface, while a projection system is a way of flattening the three-dimensional Earth to show it on a 2D surface. So there's no way to do this, unfortunately, without some distortion, which we are going to go through at length. First up, we have WGS 84, which we'll refer to as the World Traveler System. This coordinate system is a system that you would use to cover the entire globe. It's like a universal map that keeps you oriented no matter where you are on Earth. WGS 84 is not to be confused with EPSG 3857, which is a web-friendly projection, which is commonly used by companies like Google. It'll be typical in any sort of web projection that you see. So the purpose of WGS 84 is a global reference system designed for positioning and navigation with true geographical coordinates, while EPSG 3857 is a web-friendly projection that simplifies map rendering but distorts the Earth's surface, particularly at high latitudes. WGS tends to provide more accurate geographic locations with minimal distortion, but EPSG sacrifices some accuracy, especially in terms of area and distance, in favor of faster rendering and user-friendly map interactions online. Next up is UTM, which is Universal Transverse Mercator. This is what we're going to call the Urban Explorer map. Picture yourself as an urban explorer navigating a city with a grid layout. UTM breaks the world into zones, making it perfect for detailed local maps without much distortion, just like finding your way through a complex city. While UTM is excellent for local accuracy, it divides the world into zones that were originally designed by the military and colonial powers. This division can be seen as arbitrary and doesn't always align with the natural or cultural boundaries of the regions it's applied to, which can be problematic. This projection is probably one of the most important to remember, the Mercator projection. Why is it the most important? Well, first of all, it is the most popular map used for global portrayals. And secondly, it is also the most controversial. The reason being that it stretches the northern regions, so thus it makes North America and Europe look much larger than the southern hemisphere. And while we may think that this plays only a marginal part in how we see global power, imagine we're seeing countries as being half the size they are. So I decided to do a really quick case study so that we could look at what effect projection has on looking at a three-dimensional object. I have used my own face for this because it seems unkind to use anybody else's. If we look at this first picture, if I project the top half of my head, I kind of look like a little alien, versus the bottom half of my face and I'm like Jabba the Hutt. we're still not capturing that roundness because we're seeing it in a 2D plane. There's no way to get around this, but looking at the Mercator system and how prevalent it is in mapping systems makes sense on why most people misperceive the size of different countries, which could also influence how they understand the population density. If we consider that landmass and that subconscious idea of population and power, there's a reason that so many people pipe up about the Mercator system. Now, this one can be remembered by the Old Man at Sea traveler map or the Navigator. When you think of Mercator, ocean, it preserves straight lines, making it ideal for navigation. The last one that I'll mention is the State Plane Coordinate System. This one we can refer to as the local guide. This is perfect for mapping regional or state maps, and it comes with very high accuracy. However, it caters to the US, so I would not use this on any other global portrayal. To recap, UTM is the urban explorer, WGS 84 is your world traveler, Mercator is the navigator, the state plane is the local guide. Each of these has its own strength, and knowing which one to use will help you make the most accurate maps and understand the differences between different maps you might be looking at and their odd distortions. So this last part, I'm going to walk through how you can actually change the projection in QGIS, and it's quite simple, but it is something that will cause you problems, confusion, and significant lags in your work if you're not familiar with the fact that you could be importing data that is from a different coordinate system. So it's a good background thought to have about the coordinate system used on any map and then adjust that as needed. If you go to Project in the menu bar and select Properties, you'll see the CRS section. Here you can set the coordinate system for your entire project. QGIS has thousands of projects available, but the most common ones you'll encounter are WGS 84, which is the global system, and local projections like UTM zones. For example, if you are working with data from a specific region, you might need to reproject your layers to a local CRS to reduce distortion. To do this, go to Vector, Data Management Tools, Reproject Layer, and select the input layers and choose the desired CRS. If you found this video helpful, please hit subscribe. And if you're interested in learning more about the field of information design, that is visual storytelling that engages your audience and actually increases retention of the information that you're portraying to them. Let's say that even you're a student or a researcher just looking to present your information better. This is visual storytelling. And I'm going to be covering the tools, techniques, and software that you can use to improve how you're getting your information across and how many people you're able to reach. So stick around for those videos, and thanks for watching.